Hello there, Algebra 2, and as promised, here is your video for how to do the review from Chapter 5, Number 3. Here we go. Let's see, if you were in class on today, Friday, then you got number 1 done, so you could skip ahead to number 2. And of course, it will allow skipping, but if you missed class today, then here is what we're doing. If it says we're supposed to show something, then usually what you want to do to show something is leave one side completely alone and force the more complicated side to look like the easy side. So what I'm going to do is, let's see, I want this to somehow end up looking like a negative log b of x. And so I want to use whatever I know about logs to rewrite this thing. And well, looking at this 1 over x, do we have a way of rewriting 1 over x? And it's true, we do. 1 over x is the same thing as x to the negative 1. So we can rewrite this side here as log base b of x to the negative 1. And then we'd want to have another good idea about logarithms. And if you have the good idea that this negative 1 exponent could really be swung out to the front, it's true. This is negative 1 times log base b of x. And sure enough, that equals negative log base b of x. We're done. Let's move on to some of these scarier looking things. So scary thing number B. Looking at, say, this part, because this should look familiar, 1 over x to the 5, well, we could rewrite that as x to the negative 5 times log base 5. Not times log base 5 of that. Sorry, Mr. Carter's coming in. Come on. I'll hit pause here. All right, everyone's coming to visit me today. All right, let's see. So we rewrote this as log base 5 of x to the negative 5. This part here is looking really scary. This cube root of x. Well, the cube root of x can be written as x to the 1/3. So that's what I'm going to do with that part. So I'm going to rewrite this part as 6 times log base 5 of x to the 1/3. Okay? And we want to make it look like negative 3 times log base 5 of x. Well, maybe you're having a good idea that you could take that exponent and swing it out front. And you could do the same thing here. Take this exponent and swing it out front. And so if I have 1/3 times 6, 6 times 1/3 is just 2 times log base 5 of x. And then if I swing that 5 out front, it's minus 5 times log base 5 of x. And if you think about it, what we really have right now is 2 times a thing minus 5 times a thing. And 2 times a thing minus 5 times a thing is negative 3 times the thing, log base 5 of x. And we're good. Let's move on to number C. Number C says, well, I bet you have a good idea for what to do right here. You could rewrite that. This is 3 times log base 2 of x minus log base 2 of x to the negative 2. And maybe you have a good idea about swinging that exponent out front. And so what we get is 3 times log base 2 of x. And negative 2 times this negative makes it positive 2 times log base 2 of x. And once again, what we have is 3 times a thing plus 2 times a thing. And that equals 5 times the thing. And part D, so I'm hoping that when you're looking at part D, you're looking at this fraction and knowing exactly what we're going to do. We're going to say this is log base 7 of x to the negative 3. And here, this is very scary looking. Okay, it's the 5th root of x squared. And you can take the fifth root of anything and write it as that thing to the 1/5. And so that's what I'm going to do. I'm going to say it's 5 times log base 7 of x squared to the 1/5. And at this point, we'd want to have a good idea. We want to have that good idea twice. Actually, 3 times, but you'll see that in a second. We can pull those exponents to the front. 1/5 times 5 is just 1. So we just have 1 times log base 7 of x squared. And we'll pull that -3 out front, and so it's -3 times log base 7 of x. And once again, we can pull this 2 out front. And so what we have is 2 log base 7 of x minus 3 log base 7 of x. And again, we have 2 times a thing minus 3 times the thing, which is -1 times the thing. So this is -1 times log base 7 of x. All right, everything else in this assignment is probably going to seem a lot easier. Number 2, just solving equations. So here we go. Here we have 2 log statements, and we can combine log statements by multiplying the guts. And so I can write this as log base 3 of, if I multiply x times x minus 2, I get x squared minus 2x equals 1. And then we want to rewrite this in exponential form. 3 to the 1 equals x squared minus 2x. And if I subtract 3 from each side, I can make it equal 0. 0 equals x squared minus 2x minus 3. I can factor both of these, or factor this side rather. I don't know why I'm doing both of these. I'm tired. We have an x, a 3 times 1. To get a -2, I believe we need a -3 and a +1. And now we have some answers. X can equal 3 or -1. It's a really good idea to check your answers in your original problem. Because here, if I check -1 right there, what we get is log base 3 of -1. And then also plus log base 3 of -3. And 3 to any power is never going to equal -1. And 3 to any power is never going to equal -3. Because I've graphed this in other videos, 3 to the x looks like an exponential function. It has an asymptote on the x-axis. It's never negative. Down here is negative. So this answer here, this -1, doesn't count. Let's take a look at the next problem. Number B, again we have a log plus another log, so I'm going to multiply the guts and make this log base 4 of x squared plus 6x equals 2. And rewrite this in exponential form. 4 to the 2 equals x squared plus 6x. 4 squared is 16 plus 6x, not bx, and then we can subtract the 16 from each side. And I get 0 equals x squared plus 6x minus 16. And we can factor x, 8 and 2, get a positive 6 and positive 8, -2. And so x must equal -8 or positive 2. And again, I'm going to check that -8. Because right there, if I plug -8 in there, I get log base 4 of -2. And so that's a no-go. But the 2 seems to work. We can check it. If I plug 2 in there, I have log base 4 of 8 plus log base 4 of 2. And if I multiply log I multiply the guts, that's log base 4 of 16, which is 2. So it works out. Moving on. Kaboom. Number C. Oh, this is a nice straightforward one. 3, just rewrite it in exponential form. 2 to the third equals x squared minus 22. That's 27 equals x squared minus 22. I add 22 to each side. I get x squared equals 49. And so x could equal positive or negative 7. Now, let's face it, if we plug negative 7 in for x, is that still a valid answer? It would be, because then we'd square it anyway, and we'd get positive 49 minus 22. So this is going to work out. Either one of these, either the positive or the negative answers work. So both answers. On this one here, we've got a log statement minus a log statement, and we can combine those by dividing. So log 8 of top over divided by bottom, x minus 5, equals 1/3. And now I'll rewrite it in exponential form. It's 8, this is 8 to the 1/3 equals x plus 2 over x minus 5. 8 to the 1/3 is the cube root of 8, which is 2. X plus 2 over x minus 5. I'm now going to cross multiply, so I get 2x minus 10 equals 1x plus 2. Here we go with solving. Minus x plus 10 plus 10. X equals 12. I'm just going to check it right there. 12 and 12. That would be 14 over 7. Yeah, that's true. 12 works. A, B, C, D, E. Let's see. E. Well, this is looking messy and ugly, and so I'm thinking a good idea would be in order. This guy right here. And my good idea is to take that 1/4 and swing it out front. Because 1/4 times the 4 is just 1. Log base 5 of 25 equals x. And then you could just know the answer is 2. That's one way to do it. Because 5 to the 2 is 25. Or you could rewrite it in exponential form. 5 to the x equals 25. And then make a conclusion that that must be 2. Part F looks a little scary. Part F. I'm just going to write it nice and big so that I can see it. Log base 5 of 8 to the log base 8 of 125 equals x. Well, the big idea here is that exponentiation, 8 to the something, and log base 8 are inverse operations. They undo each other. And so if we have 8 to the log base 8 of something, what we get is the something. So it's log base 5 of 125. And now we can write this in exponential form. 5 to the x equals 125. You could just know that 5 to the third is 125, so x must be 3. If you wanted, you could take the log of each side. You could say log of 5 to the x equals log of 125, and then swing the little x out front. X times log of 5 equals log 125. That's all necessary if you recognize that this is just 3. But if you had to do it on a calculator, divide by log of 5, now your calculator would tell you it's going to be 3. Moving along, part G. Part G. Well, here's what we know, and I can see how this could be a little bit confusing. Make myself some room. What we know is that if I have log of A and I add log of B, I'm going to get log of A times B. But in this problem, they threw a 2 in there. And we just can't say it's log of A to B. That's just not true. But what we can do is take that 2 and swing them up and make them B squared. So we'd have log of a plus log of b squared. And now we can combine those two statements and make it log of ab squared. So that's what we're going to do in this problem. We're going to take that 2 and swing it up top, make it right there. So we get log base 3 of 81 plus log base 3 of x squared equals 1. Because now we can combine these things. Now we can multiply the guts and say this thing is log base 3 of 81x squared equals 1. And we could write it in exponential form. 3 to the 1 equals 81x squared. We could if we felt like it. Ugh, I don't like this. Oh well, I don't have a choice. I get divide by 81 on each side, and I get x squared equals 3 over 81, which I believe reduces to 1/27th. That's why I don't like it. And yeah, and so x is going to equal the square root of 1/27th, whatever that is. There is another way of going about doing this problem. If what you recognize, if you just recognize right off the bat that here, that log base 3 of 81, 3 to the 4th is 81, so this is 4 plus that. And if we'd done that, we would have said log base 3 of x squared equals negative 3. And then writing this in exponential form, 3 to the negative 3 equals x squared. 3 to the negative 3 is 1/27 equals x squared. So we get to the same place no matter what. That's just hideous. Ms. Signorati wrote a bad problem. Let's take a look at number 3. It says graph this, f, and graph that on the same set of axes. Well, you have toolkits, so everyone does know how to graph y equals 2 to the x. It has an asymptote on the x-axis. We start up 1. That's or you could think of making an xy table. If I plug in 0, 2 to the 0 is 1. 2 to the 1. So my equation is y equals 2 to the x. 2 to the 1 is 2. 2 to the 2 is 4. 2 to the 3 is 8. Negative 1. 2 to the negative 1 is a half. So if I just plot these points, 2 is 4, 3 is 8, and there's negative a half, I get my exponential graph just like what's in my toolkit. If you're asking me, yo, Signorati, how in the heck do you expect me to graph this g function? Well, what I'm expecting you to do is think about the relationship between 2 to the x and log base 2 of x. And if it has occurred to you that these are inverses, that is a good thing. So if I take a look at my original function, 0, 1 is on my original function. So 1, 0 is on the inverse. And 1, 2 is on my original function. So 2, 1 is on the inverse. And 2, 4 is on the original function. So 4, 2 is on the inverse. So is 8, 3. And so is a half negative 1. And so this function here shows me log base 2 of x. And this one up here shows me y equals 2 to the x. So I can say y equals there. Alrighty. And as for this table, looking at my 2 to the x graph, it has a y-intercept at 0, 1. It has an x-intercept. It doesn't. The domain is what the x is, how far back and forth my graph goes, and it goes on forever. And the range, it bottoms out there almost at 0, so y is always greater than 0. Now, if you know how to cheat and swap these things, that That's a good thing. Otherwise, you could look at the graph. Let's see, this guy has an x-intercept of 1, 0, which is exactly the flip y-intercept for the original function. This red graph, my inverse function, has no y-intercept because it never is going to touch this y-axis, so none. It's like the opposite of that one. The domain of this thing, well, it's always greater than 0, so I'm going to say x is greater than 0, and it does go down forever, and it will keep going up forever, so my range is y is an element of the reals. There we go. Let's move on to number 4. Oh, I remember this one. It's pretty fun. All of these you can figure out without really doing a whole lot of work. Log base 2 of 2. That's 2 to what power? To what power is 2? So this is 1. So what we have is 3 times 1 minus 2 to what power is 4? 2. 3 minus 2 is 1. There it is. So taking a look at this guy. Log base 3 of 3 is 1. Multiplying it by the number 5. Minus log base 3 of 9 is 2. 5 minus 2 is 3. So let's put that out. Log base 10 of 1. 10 to what power is 1? Well, 10 to the 0 is 1. That's the only way we get 1 there. So this whole thing is 0. Plus, this guy here says 10 to what power is 10,000? Well, let's see. 10 to the second is 100, so that's 2. 10 to the third is 1,000. 10 to the fourth, so 0 plus 1. Scratch out a 4. See how easy this is? Whoops, I don't know why I just erased that. My answer is 4. Ooh, this one's a little weird. D's a little weird. Because I don't know 10 to what power is 2,500, or 10 to what power is 40, but I do know this. If you have a log statement, log base 10 plus another log base 10, you can multiply those guys. You can go 40 times 2,500. So I'm going to get log base 10. 4 times 25 is 100. That's 4 times 25. And then 1, 2, 3 zeros. 1, 2, 3 zeros. So 10 to what power is all this? Well, that's 10 to the first, 10 to the second, 10 to the third, fourth, fifth. So I get 5. Yahoo! That was a little tricky. Here, oh, I think I'll just do it directly. 2 to what power is 4? 2 minus 2 to what power? 2 to what power gets you the square root of 2? Well, the square root of 2 is 2 to the 1/2. So this is 2 minus a half. Final answer is 1.5. Let's see, 5 to what power is 5? That's 1. 5 to what power is 125? That's 3. And negative 2. Here, you can pop that 8 out front. This is 8 times log of 49 to the 49th, which is just 8 times 1. So that's 8. Here, let's see. If I just look at this part here, 2 to what power is 1? 2 to what power is 1? And that's got to be 0. So who cares? It's 4 times 0. It's 0. Minus 2 to what power is 8? And that's 3. So I get negative 3. I can't believe there are no mistakes yet on this worksheet. This guy, 3 to the log base 3 of 7. 3 to the and log base 3 are inverse operations, so we just get an answer of 7. Okay, you could pop this 5/3 out front, so negative 5/3 times 3 times log base 24 of 24. This whole part here is 1. So it's 1 times negative 5 over 3 times 3. So I'm thinking those 3's cancel. We get negative 5 for an answer. Same thing here. I'm going to pop that 2/5 out front. 5 times 2/5 times log base 2 of 8. So 5 times 2/5 is just 2 times log base 2 of 8. 2 to what power is 8? 3. Okay, here, again, I'm into popping those things out. That 1/3 comes out, so it's 3 times 1/3 times log base 5 of 25. 3 times 1/3 is 1. 5 to what power is 25? 2. Final answer is 2. And, oh good, log base 7 of 7 to the log base 7 of 1. Okay, well, 7 to the log base 7 of anything is the anything. And log base 7 of 1 means 7 to what power is 1? And that is 0. Woohoo! Almost there. Is this the last one? Yeah, it is. Really? It is. How exciting. Whoops. Come on. There it is. All right. So, show that each of these is the same thing as negative 6. Well, let's see. Looking at this one, do we know what log base 2 of 8 is? That's 2 to what power is 8? 2 to the 3rd is 8. Times negative 2, that is negative 6. Let's see. Looking at this, 2 to what power is 1/8? 2 to what power is 1 over 8? Well, to get the number on the bottom, it's going to have to be a negative, and I'm thinking negative 3 will work. 2 to the negative 3rd. 2 to the negative 3rd is 1 over 2 to the 3rd, which is 1/8. So this is 2 times negative 3, which is negative 6. This says 2 to what power is 1 over 64. I have a feeling the answer is negative 6. 2 to the negative 6 is 1 over 2 to the 6th, and 2 to the 6th is, let's see, whoops, 2 to the 6th is 2 to the 3rd times 2 to the 3rd, so that's 1 over 8 times 8. So I'm just going to say 2 to the negative 6 equals 1 over 64. So x equals 1 over whatever. So negative 6 is our answer here. And here, I'd square the 8. Negative 1 log, not negative yog. Actually, I wouldn't square the 8. I'd pull that negative 1 up. So it's log base 2 of 8 to the negative 2, which is log base 2 of 1 over 8 squared, which we just showed right there is negative 6. All right. That was fun. Hey, Algebra 2, I hope you have a nice weekend, and I will not see you Tuesday, but I will see you on Thursday when we have a test. See you then, people.